Okay, for example 8, we're expected to find the 27th derivative of cosine of x. We don't have to take 27 derivatives to do that. So basically we're looking for a pattern for this function cosine. And if we consider cosine as our original function, f of x equals cosine of x. I like f of x structure rather than just that d27 structure. The first derivative of cosine, of course, is negative sine of x. And the derivative of sine of x is cosine of x. The minus sign is not included with that. So the minus sign comes down, and the derivative of sine of x is cosine of x. And then we look at the third derivative. The derivative of cosine is negative sine. The minus makes a plus, so again, a positive sine of x. And then the fourth derivative, and we write fourth derivative with like a little 4 up there, like so, instead of 4 dashes. Fourth derivative is going to be cosine of x. And when we get a repetition, that means we're done. So that's one possibility for this type of problem, where you're trying to find a really high derivative like that you can see a pattern existing, that is just a repetitive pattern. So the fourth derivative is this, so the fifth derivative goes back to negative sine of x, and so on. So 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7. The 27th derivative is right there. So d27 cosine of x is equal to sine of x. If you can establish this pattern here, we have the first derivative, the second derivative, the third derivative, and the fourth derivative. And that's a 4-step pattern. They're not all going to be 4-step patterns. Suppose they ask for like the 543rd derivative. You don't want to count all the way up to 543. So the way you would do that, if it's a really big number like this, however many things in your pattern, in this case 4, divide that into the number. Remainder 3, remainder 1, remainder 2, remainder 3, remainder 0. So remainder 3 would be sine of x, so this would also be sine of x. So you don't have to count all the way up to 543. And this is one type of pattern, again, where it's just a repetitive pattern. It's like the powers of I to the first, I to the second, have that pattern. We were able to find out I to any power at that point. Some of them, a second example here I want to include here is the 49th derivative of x cosine of x. It's a building pattern, and it's not necessarily the same as what we just saw. So if we look at x cosine of x, what we're noticing here is if we consider our original function f of x, which is x cosine of x, this is a product of functions, so the product rule is necessary to differentiate. So if I go f prime of x equals, and do 1d2 plus 2d1, that gets me f prime of x is equal to negative x sine of x plus cosine of x. And I would recommend that you do your derivative somewhere, and you put your simplified derivative kind of in a list here, so you have this nice list. So the first derivative, I'm going to put a 1 next to it here. I'm not sure how many things in my pattern, but I want to establish an order of things. That's the first derivative. Now if I go on to try the second derivative here, from that, again, just doing some scratch work over here. So the first term, negative x sine of x, is a product. So if I go f double prime of x, and I'm differentiating this piece of it, I'm using the product rule. 1d2 is going to be negative x times the derivative of sine, which is cosine of x, plus 2d1, that'll be plus sine of x, times the derivative of negative x, which is negative 1. And then I take the derivative of cosine, which is minus sine of x. And if we simplify this as much as we possibly can, the second derivative ends up being negative x cosine of x, and then minus sine of x makes minus 2 sine of x. Again, I don't have enough yet to establish a pattern, so I need to keep going. So now we're going to the third derivative. Okay, Okay, so I got a product and I've got just a sine function, so it's a lot like this, but just different stuff going on. What I'm really looking for in a situation like this, I'm looking for this to happen again, exactly the same thing as that, which it hasn't happened. That's almost the same, that's negative x cosine of x, but that hasn't happened again yet, so that's kind of what I'm looking for. So I'll go for my third derivative here off of this one, f triple prime. If I do 1d2, it's going to be, for this first term, I'm going to get negative x times derivative of cosine is negative sine of x, plus 2d1 is going to be plus cosine of x times negative 1, and then derivative, so minus 2, derivative of sine of x is cosine of x. So we can see here we get f triple prime of x. If I simplify it as much as I possibly can, I get a negative, or positive x sine of x. And I get minus cosine, minus 2 cosine, so a total of minus 3 cosine of x. So f triple prime of x, simplest form right there, is x sine of x minus 3 cosine of x. Moving on to the fourth derivative. Again, I haven't hit that x cosine of x again, so going on to a fourth derivative. Here's my simplified third derivative. So 1d2 is going to be x cosine of x. 2d1 is going to be plus sine of x times 1. And then minus 3 times derivative of cosine is negative sine of x. So altogether, my fourth derivative comes out as x cosine of x. And then we got plus sine of x, and this will be plus 4 sine of x. Okay, and that's good because I'm back to x cosine of x. I got this extra term, but it's not expanding out. So my initial derivative got me 2 terms, and I stayed at 2 terms all the way through. So what I want to do is compare the terms to the original problem. The first term is where we get to the exact same piece. So I can see a 4-step pattern here. And the second term is alternating between cosine and sine, some sign changes happen, and we've got some numbers here. Compare the numbers to the derivative number we're on. So the first derivative we have 1 cosine of x, second 2, third 3, fourth 4, and so on. So I can see that whatever derivative number I'm on matches this number here. I can see the alternating sign, so again I can see kind of where I'm going. I need to compare what my answer is going to look like to one of these 4 pattern pieces. So the first piece will be whatever it is. The second piece will have the correct sine or cosine, correct sign, plus or minus, and then the correct number there. So we're looking at the 49th derivative. It's a 4-step pattern. 4 goes into 49, 1, 2, remainder 1. So we're going back to the first derivative structure, which is this structure. And that's not what the derivative is, but the 49th derivative we can see of x cosine of x should equal this exact first term, negative x sine of x. That's all that's happened in the first term, just negative sine, negative cosine, positive sine, positive cosine. Each time with an x, it just keeps on going back and forth like that. The number, I'm here at plus, so it's going to be plus. This number matches the derivative number I'm on, so 49. And this function's cosine of x. So I should expect that to be my 49th derivative if I continued on in the process. So that's more of a building terms, where this is more of a pattern of terms. And those are the types of things you're looking for in these problems. Is there a build, is there a pattern, is there a combination of the two? If you do see some sort of a pattern, if the exact same piece shows up in your answer anytime whatsoever, then that represents a spot where that pattern has completely gone through the full cycle. So you can stop there and then kind of compare everything else to what derivative number you're on, or whether the trig functions are alternating back and forth, signs are alternating, that kind of stuff like that. So there's 3 homework problems like this, if I remember right, and one's challenging more like this, the other 2 are more like the first example that you saw.